from the Mediterranean and was introduced to the Americas, but there are figs all over the world. And all of them have in common that their fruit aren't really fruit. They are extensions of the branch, and it's grown around the flowers. The flowers are really on the inside. The only way that these flowers can be pollinated is if an insect crawls through this little hole here. This is done by wasps, and it's not only one genus of wasp, it's a whole group of wasps, but each species is specialized on one kind of fig. So the Mediterranean fig that the first Spaniards brought over here and had in the missionary gardens, eventually they had to bring over the wasps too, and there are several species of wasps here now. In Arizona we have this one with totally unpronounceable name. I won't even try because I pronounce it in German, which is a little easier. But anyway, I don't know whether the first ones came over inadvertently with the first fig trees, or whether they were imported later when scientists understood what was necessary, and the figs until then were just producing infertile fruit. Some figs would abort those unpollinated fruit, but I think this species doesn't, because our neighbor planted a little tree and I've opened a lot of figs and there was never a wasp inside. These wasps are the ones that fly the furthest of all pollinators. So if there are some in California, they could find the little fig tree in my neighbor's garden here in Arizona. They fly that far, but I'm not sure they're necessary. But if you want figs that are actually producing fertile seed, then you do need the wasps, and the female will crawl in. It will pass male flowers here in the outer part of the fig, and then get to the and get pollen on itself, and then it gets deeper into the female flower area, and it will leave its eggs there. The eggs will develop into larvae and go through the whole cycle within the fig. The males will hatch first, as in most wasps. They are wingless. They will never really leave the fig. They probably die in there, and some make it out, but they have no life outside of the fig. They mate with the females in the fig. If they are lucky, there were two females laying eggs, and they're not their sisters, but wasps are not that particular. Most insects aren't. So the females that are impregnated then will eat their way out and start the cycle again. So this wasp has evolved to the point that it can only live within the fig, and the fig has evolved to the point that it can only produce fertile seeds with the help of the wasp. We have an example here in Arizona, a native example in our yuccas, the soap trees, and here, I don't know which yucca this is, but then there's the banana yucca. So we have several species. We also have several species from two genera of moths that are necessary to fertilize these, to pollinate these yuccas. And it's a real interesting behavior that this little moth has to go through. It collects pollen from the anthers, forms it into a little ball, and then actually stuffs it into a pore of the female parts of the yucca. So it looks as if it understands what it's doing. And it also lays its eggs onto the stylus, or into the stylus rather, because the larvae will then develop together with the seeds and eat a lot of the seeds, but not too many. So the only way that this yucca can produce seeds is with help of the yucca moth, and the only place for the yucca moth to have larvae is the yucca, so they're extremely closely tied together, and that is an obligate pollination mutualism. So all the interesting, ecologically fascinating pollinators are really the pollinators in an ecosystem with wildflowers or with wild trees. We have their interdependencies that go far beyond just the flower and the pollinate. Oops. And we have the seasons as a complicating factor. It is thought that a lot of plants bloom in very unlikely times of the years, like snowdrops very early in spring, or the desert broom here very late in the year, because that gives them an advantage in the access to pollinators, because there isn't that much there at that time that's blooming, but pollinators are around. So you can see that everything concentrates on the desert broom, for example, that blooms in nearly November. Or the brittle-bush gets all kinds of bees. I've done a study in my own backyard. I got hundreds of different bee species there, just on brittle-bush, and there's really not that much else blooming in the desert. So plants use these niches to really ensure that pollinators will not stray to other species, but stay with them. These highly evolved systems are, of course, also very vulnerable to disturbances. If a pollinator disappears that has to pollinate the yuccas, then the yuccas don't get any fruit. And that would trigger a whole series of problems in the whole ecosystem of that area. In the highly industrialized agriculture that we have nowadays, we have these big monocultures as opposed to this high diversity. And the generalist pollinators like the honeybee are of course very useful there. They also are available all year round because not the single honeybee lives that long, but the hive is there the whole year and it can be transported. Whereas all of these other pollinators, they are adapted to the flowering times of their flowers, and they will not be available all year round. They will also not necessarily produce large numbers that a whole field of canola needs. So there are some advantages for the prevalence of honeybees in agriculture. It has now been tried to use other pollinators, especially with the hive collapse problem, and they have actually gone to breeding flash flies, because flash flies are unpleasantly bred but easily produced, and they of course cannot pollinate all the flowers. They are only good for example, carrot fields. They can pollinate the simple umbelliferous flowers, or they can probably do something with some rosacea, because they're also very simple. They could pollinate cactus, but I don't think that's a problem. So there are attempts made to use other easily bred insects for agricultural pollination. But there is, of course, the native flower compensation area, which I think is a great partial solution at least. That would be like an old-fashioned hedgerow area that goes along the fields, or maybe crosses the fields even, where native plants and native pollinators are allowed to thrive, and